Hey, 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 everyone. I don't know if that came off a little quick, but it looks like it worked out pretty good. How are you doing there, Daniel? Oh, I think he's still muted. Ah.
Oh, that's
Unless.
weird. I didn't mute myself. It automatically muted somehow.
Oh, well, welcome back.
Sure.
I was like worried. I'm like sitting there going, oh my God, there's something wrong. I'm checking everything because, of course, we're live. And, of course, literally within the first 5 seconds, please let something go wrong. That would be just great.
Yeah, I did not press the mute button. I could see that it was saying muted, and I thought it was auto muting for some reason.
Gotcha.
There's not very much background noise, but it's the same setup we usually do for our daily space weather videos. So, it's
perfect. I'm slouching in my chair for like no reason whatsoever. So let me just get all pretty there for the camera and make sure that we're all, good. There we go. So that's all. Woohoo! Working out. All right.
Yeah, let's do this.
So let's see. We have the Duffster. Of course, Daniel's here. He's a gentleman who actually runs Smash OMash and channel. It's in the description of the video. Plus, we're looking at, he wanted to talk about stellar anomalies. He has a whole thing planned, so we're going to let him actually take control of the screen there once we get going after the preview here. But I want to introduce everyone. Of course, we have Gareth from See the Pattern. We have Buddy from, of course, the Buddy Doherty has his own channel, which is very respectable in its own right. We have Chris from Take Back Space. Rick, of course, is here. We have Sean. We have Jim. We have, of course, James Conway. Ignore the other. That's just a phone copy. It's second Duffster. He's just, and then, of course, me. We actually expect to have Tanveer pop on. Hopefully, we want to have as many physicists and astrophysicists as we possibly could, since the subject, of course, is going to be more or less the anomalies that we see out there in space. So before we get going then, Daniel, tell us what we're going to be seeing there.
Cosmic ray flux. Oh, geez. All right. So where do we start? I guess just get right into talking about the composition of your most local Birkeland currents, right? So the goal is I want to talk about Birkeland currents, but not on a level smaller than, say, the size of Earth, right? Earth and larger.
Right.
Stick with cosmological. So is somebody screen sharing now? Because I have no idea what's being displayed on the video. I can't see it.
Well, actually, you are taking up the majority of the video. It has a little description. I'm literally doing the whole Skype thing. I'm in the corner. We have the channel and everything. It's just the channel for 24 people are watching us right now. Actually, we didn't even get a chance to even say hi yet. Some of them have popped in, but I was going to do that before we once we get everything rolling. So
yeah.
But you can share the moment you want to. Go ahead.
Yeah, I have this whiteboard set up. Let me just press screen share.
Oh yeah.
I think I can just do the application window and that should work. There you go. Now everybody can see the whiteboard?
No.
Still me?
Still your face.
Oh, wait. There we go. Start sharing.
Aha! There we are.
Oh, there we go. So we have the whiteboard.
Woohoo!
All right. So there's my crew. And so that's the whole screen now, just the whiteboard.
Well, except for my little body in the corner. Don't worry about me, though.
Okay. Right on. So, there's my crew drawing basically the Birkeland currents or the Earth's
fancy
Z fields, right, on my public whiteboard. And you can gladly come and graffiti it up now again if you like. Everybody in the Skype call does have the ability to click on the link there. And you put that in the description afterwards if you like.
Well, yeah, I have it right here, too. I don't necessarily want to share it with everyone, though, so.
So anyway,
because it would be public, is what I meant.
It's okay. Just please don't draw over anything that we already have in place.
No, I'm just being. There's bound to be one troll. So don't worry about it.
Oh, it's like an interactive whiteboard. That's cool.
Yeah.
Yeah. That was kind of the purpose, just in case anybody has to add anything in. And so, ultimately, what you're going to have there is you've got a Birkeland current going in both ends of the Earth, right? I mean, I think everybody pretty much agrees on this nowadays. I mean, it wasn't really agreed upon until the 70s.
The image that I just put up there is NASA's depiction of the actual, the green and yellow there. That's how it comes off of the sheet that I think is a magnetic field line area.
Right.
That's straight from NASA's website.
Yes, and I would imagine that the Birkeland current is probably rotating in one direction, coming out of the one pole, and the opposite direction coming out of the other.
Actually, there are multiples. There's many of them. You see, it's like think of them as spaghetti, and twisting towards that sheet of magnetic
more
field
obviously
lines.
like ravioli. No, wait.
No, spaghetti.
We've been going.
What has a hole in the middle? Like, I don't know the one you like. Is it?
That's what Gareth and I were talking about. I think that is the area of
The cinnamon roll
anomaly of gravity, where if you can picture it, the sun is 90 degrees to that hole on the left-hand side of the Earth there, and I think that's where the gravity anomaly takes place inside that
now,
whole circle.
You mean to think? Well, that's, if I'm not mistaken, and I'm probably not. I think that pretty much points at our magnetic pole right there and why it's moving. The green stuff at the top, assuming that's the north side of the planet,
right?
Which is the south magnetic pole.
I would agree.
All right, and now.
And so the Earth has a B field, which is the one you primarily live on, which is like this. You know what I mean? The Earth's B field is like this. You've got Hall currents that form because of this. The Earth acts like a transformer, right?
Generally speaking, yes. A weak one comparatively, but yes.
Yeah, you've got a semiconductor known as the atmosphere, and and so on. That's kind of the way the Earth kind of transforms this current coming from elsewhere at a place known as the sun. So here's a Gong 2 image, which draws in the sun's B field, shown in blue, right here.
You can actually see those on the either side of pictures of Jupiter and Saturn, which show this field.
Right. And the point is, the sun has coronal holes that never go away on both the north and the south pole. And so if you think of it, and now recently articles have just been published actually in the past couple of weeks about how we literally do not know if the Earth, the sun, the solar system, the galaxy, or anything else are gaining or losing mass. So when you think about this from the perspective of where's the proton beam coming out of and where's it going to, it starts to get pretty interesting on the even intragalactic scale, I think.
Ah, okay.
We've got physical object. So now let's go to a scale
actually, before we go any further, because this is the perfect opportunity, I'm going to actually say hi to some of the people that are listening, and then
cheers.
Because this is, it's awesome that they're here. And I don't know, did you see any people who were, I mean, I'm very happy that I see a few people here. I mean, even Gareth is sitting there talking, and yeah, I can understand why he went with Picard.
Well, yes, Starlight Spectrum's here, Polly B's here, Marguerite and Renegade, and I believe that is Cognitive Dissidence that is using those Jewish characters. I think they're Jewish characters. I'm not sure.
I think that's Arabic, actually.
But they're ancient.
They look awesome.
Ancient Arabic. Okay, yeah.
It has a little symbol in it. Anyway,
welcome everybody.
I'm going to actually.
And those that haven't texted, sorry.
No, go ahead. Sorry, and hi Ryan. There's Smash. There's Daniel going right there. Cronus is here too. Perfect.
Yeah. Welcome everybody, including me, because I'm not only Smash OMash, I'm also a client.
Forgot to mention Centrix B and Lewis. Welcome, and Ether Revival, sorry, my bad. And Michael Wise is here. Welcome.
All right, now
Welcome to the October 20th edition of The Electric View. I'm Neil Thompson. Today, we are discussing the fast ray bursts that are coming up in the news lately, and other anomalies in astrophysics that commonly go unmentioned, like the Pioneer anomaly and flyby anomalies, with our good friend over at OMash. Please take a moment to like and subscribe. All right, looks like we're back. Hey guys.
All right. Greetings, Earthling.
Yes.
All right, so
go ahead, man.
Are we good to go?
We're good. You're up. The whole thing is rocking and rolling.
Okay, so you've got on the right here. This is a fairly detailed, a very detailed image of essentially the Earth's electromagnetic flux ropes. Let's just call them, right?
I have a different name, but we'll go with this for now because the conventional. Yeah, we'll use the bunny rabbit ears.
Yeah. This is kind of the part of the current sheet that's interacting with the Earth directly enough to, from this scale, to say directly, right? Yeah, you've got plasma. You've got plasma. It's being split based on polarity at the edge of the magnetosphere at the bow shock area. It's going to have, the plasma is going to have a tendency to spin like that and create these Birkeland currents, and each one is probably its own series of flux ropes upon flux ropes.
Actually, right? That's exactly what we seem to notice at the first depictions, as we were talking about in the sci-fi episode last week. One of the things that we noticed is, or what that mentally happened, is that we had pictures of nebula and we imagined them as clouds. So they became clouds in our artwork. But in popular culture, Star Trek, all the way to, of course, Battlestar Galactica, where I saw a few clips of the old stuff. Now you go all the way to now, and you look at the real Hubble telescope pictures, and you can see that they are themselves made out of smaller fibers, tendrils. So just
right.
as you described.
Okay, right. Anyway, I just wanted to make sure everybody's on the same page of what I'm talking about.
I think we are.
So there's a crude drawing of the Earth. Here's the drawing of the Sun. We've got the B field out here. This is the one we live on. This is the interplanetary magnetic field, essentially. And basically, one thing that we don't know is how much of this stuff is coming back like this, and how much of this stuff is getting blasted into space like a rifle, right? Because some of the material, as we know, there are coronal holes that are persistent on both ends of the Sun.
Mm-hmm.
But some of this stuff is going to rain back down through various different features, whether it's electromagnetic features or gravity or whatever. That's for a different show. And so in most of these areas, you've got a bunch of plasma ionic particles, and it all wants to form into these sort of patterns, right? Birkeland currents.
Generally speaking, yes.
So when you zoom out to a larger scale, now this is the composite image with Chandra as well as radio.
Yes, and
Cygnus
X-ray or whatever.
Yeah, so Chandra X-ray, radio, and I think visible on here also. I can bring it up.
Actually, we can see the difference. I think it's blue, red, and white.
This will actually show. This splits them. No, maybe not. Oops. Anyway.
I was just going to mention that there's 10 million amps of power connecting on that that field line, the sheaths connecting the green and yellow. There's 10 million amps of power running through that.
Wait.
This is why.
No.
This is why.
How do you know this? Because last I heard, it was 100,000 amps, and all of my calculations have been on 100,000 amps.
I've been listening to Wallace talk about how much, and Andy Hall talk about how much power is coming out through the solar circuit.
Oh, okay. Sorry, I just actually wanted to know. I was the last official from like NASA or something. Sorry if they did calculations on that, because I mean
these are parrotings of the EU theories.
Okay, no, it's quite possible that they are. but I was, the last one we had was from, I remember it in 2009. It was Dr. Donald Scott was at NASA, and he was at the Goddard Flight Museum or Space Center or whatever it was, and he particularly brought up the showing the current connection of about 100,000 amps powering the solar aurora, basically. And, you know, that was basically the last official number that I had that gave anything like that. So I was very interested in that, a new number. But I mean, obviously I'll take Wall's word for it. But, you know, I'd like to hear it from, like, if NASA managed to do a calculation on that or something. That's all. Go on, please, Daniel.
All right, so we're talking about Cygnus X-3 now, otherwise known as Deneb. This is from our galaxy.
Right.
Yeah, and I didn't start studying this by accident. Like most things, it was on purpose. and the reasoning behind it was essentially because of Göbekli Tepe. I was like, how come everything was pointed at this? It's the opposite end of the precessional, you know, it's the other North Pole at the other end of the precessional cycle, right? And so that makes it an interesting object in that it could be associated with the celestial North Pole of the Earth. Obviously it is. And so the point of this image here is the fact that the one jet is pointed right at the Earth.
Right.
And now, similar to the sun's jets, now this star is, I was reading the article that we were just on, which was talking about its discovery in 1972, which was, I believe it was discovered by an under Granite Mountain Russian nuke detector.
Okay.
And the 4.8 hour periodicity was discovered because it would seem to shut off every 4.8 hours. So the theory is that the Wolf-Rayet star, which is a blue giant, it would be about the size of, I believe, Mars's orbit if it were in our solar system, is being orbited by this, quote, neutron star, end quote, every 4.8 hours.
I automatically, and that is bullshit I smell, but please go on.
But the output speaks for itself. And if you're in the northern hemisphere, this blue jet here has sent physical items. It's reached out and touched someone. And when I mean someone,
I'm not saying
you.
It's not real. I simply meant the reasoning. But go on. Neutron star.
No, I understand.
Yeah.
But the protons don't lie.
I would hope not. No.
And since they seem to be getting here from there, since this is how, you know, it was figured out because we had this nuke detector and we're going, how the Russians are out there and they're EMPing us and they're shutting it off every 4.8 hours. And then they're like, wait a minute, what's going on with this? What is up with this X-ray source? And so anyway, the point is to bring it back to the sun scale.
Right.
Where do the sun's Z fields get to? You know, the Earths are at a 90-degree angle. You know, the Earths basically go to the sun. But where do the suns go?
You literally enter into Jim's world.
Well, yeah, and it's certainly not to Sagittarius A star. There's way too much stuff in between.
Oh no, especially not a direct route. However, for some reason, and I'm not sure why, we do happen to have a lot of things on Earth, like radioactive decay rates, that are dependent on the sidereal day or the direction we are facing towards the center of the galaxy. It's very odd, but
that is odd. It's creepy.
Yes, it's like it directly affects us somehow. It's like the center of that controls the properties of matter here, and in an instant, like as Wal Thornhill would say, sort of way.
Right. And this is not information I like to tell people. It just happens to be true. Because
it creeps me the hell out a little bit. Yeah.
I say this all the time in my space weather videos. The magnetic environment can change violently and instantly with absolutely no warning, as far as we currently know. So, I mean, that's not good to know. So, anyway, the point is, what I'm trying to state here is that an object that's believed to be somewhere between 1,800 and 20,000 light years away is clearly sending protons all the way to your brain. That said, let's start talking about the brightest object ever imaged.
Now we're talking about, when you talk about the transfer, we're talking about cosmic rays able to penetrate directly through all of our protections.
Yeah, I mean, it's
Any matter.
It's pretty much the best known point source for cosmic rays, and
that wouldn't surprise me if it was relatively close. And Dr. Donald Scott describes this in the book The Electric Sky, regarding specifically how much power giant stars, like you were describing, would have in the ability to send cosmic rays. Like, I mean, significant amounts of power, like like a million orders of magnitude beyond our sun's ability to send them. So they would, some of these protons would have the ability to pass straight through the protective layers of almost any star.
not to mention that, though, an object like this could be powering the sun. If it's that reliable of a cosmic ray source, and it appears to be, I mean, look at the X-ray flux over here on the right side. Look at this over here. It's got this multi-year periodicity as well as this 4.8-hour periodicity.
I see what you're saying.
The question is, which other high-mass X-ray binaries? I mean, is a star formed because of a pickup sticks kind of a scenario where there's a whole bunch of Z fields that are all kind of aimed at the same spot, the same point in space, causing something to ionize there? Is that the progenitor of like a star, perhaps?
Well, there's lots of there's lots of opinions, and because we enter into that anomalous point where one of the first anomalies we can simply mention straight up is the trouble with the solar mass. You know, we see things that appear to be, is it hydrogen, liquid metallic hydrogen? Is it that light? A lot of people are going, it's iron on the surface. You can see the mountains, and, you know, you have all these discussions and so forth. And we can see ripples across the surface, so it must be a liquid, but what's going on here? Is it hollow? Is it solid? What's the pressure? You know, we're all guessing. We can measure certain things, including luminosity, but we're really just scratching the surface, much like we're scratching the surface under our own feet.
Right. And
I truly think that energy, I truly think that energy is the basis of everything. And if that's the case, then energy will change gravity and mass and magnetic fields just like that.
Well, this is one of the things I was thinking about with regards to the controlling of properties. Now that I can see, that has to, like Sagittarius A controlling the properties of the galaxy, or even an influence from that high source binary that you're describing in Deneb, that type of thing being the overall electric field properties, or basically the underlying fabric of reality, maybe. These words coming to the plenum sea of electrons and cosmic rays that allow all electromagnetic light to travel. I don't know what we're talking about exactly, but that kind of stuff.
I hear
the ether, maybe, but
that does not sound crazy to me at all. It sounds crazy to say it doesn't sound crazy, but it doesn't sound crazy.
Well, and we can see
the other thing that they're talking about is basically the idea of inflation, that things are that far apart, and I don't believe that at all. So I think things are a lot closer, maybe 1 billion times closer than they actually are.
And we obviously have some evidence of that, what I'm willing to go into in a minute, because it's, I mean, Holt and Arp alone, James is right on the money. But go on, Daniel.
Yeah, and that's a perfect segue into what's on the screen now. I mean, can you guys see this?
Yes.
there's Cygnus A in radio, one of the best examples of radio jets, and then probably plasmoids coalescing there out at the ends. And then here it is in X-ray. And the interesting thing about this, here's the composite, but here's what it looks like. Look at how stunning this is. Look at that 90-degree angle there. It looks utterly unnatural, like a square.
You mean right in the middle, or the whole thing?
Around the very center portion. Can you see my cursor?
Looks like a spiral galaxy.
Around the central portion, it looks like an N.
Yes, clearly.
And then if you look out,
what is the object in the middle? If I might be so bold, is that just a star, or
that's Cygnus A, man?
Oh, you mean that's a galaxy, or
yeah, what? That's it. That's this.
Okay, so those are the radio lobes, and so that's the combination of X-ray source, visible light, and radio waves. Is that correct?
Yeah. Yeah, and this is the Hubble image. This is what it looks like just through visible.
So that's incredibly
damning. Can I jump in on the
geometry? Please.
Yeah, so you were saying that like it seems unnatural to have a square or diamond or something like that, but I want to reiterate from my kind of findings that squares, hexagons, pentagons are really natural, actually, and found everywhere in nature. We just haven't looked for them for so long, so that they seem really mysterious. But like right now, even around the end center portion, if you go back to that one last shot, there's a square in the stars around it, like a diamond.
That's the trouble.
Formation of the boundary layers of the pressure mediation of a sphere growing outwards from the center of an oscillation, and then meeting another sphere shell and pushing and making walls. Okay.
You might be right. I just mean I don't know the distance of these stars from each other. That's all.
Okay.
I guess my question would be go back to the image with the with the right angle. Is how big would those jets be in that image? That was my question is, because
I think they're believed to be about 200 million light years in length.
No, I mean in that second image, does the edge of where we think those potentially plasmoids form on the outer edge, so the red pinky part in the diagram, you flick to the next picture, is that where that right angle, no, the other one, is that where the right angle forms, or is that right at the center, the little circle?
The right angle is like a dust lane. It's like an area where there looks like there's nothing in the optical.
So if we go back to that image where the N sits, then exactly where that N is exactly where that total image that we saw in the previous one is. So therefore, where that 90 degree sits is a significant distance further than the edge of the pink bit in that previous image.
Well, yeah. Well, if that's
no, it's not zoomed. It's the same zoom on all these images.
Oh, okay. So that's okay. Right, gotcha. So it actually overlays. It goes beyond it then.
Yeah. Well, that's what I mean. I mean, that's a galaxy, and
that's the dust lane. These outer plasmoids are like pulling the material out of those areas, I think, or we can't see it for whatever reason.
Well, that would be no. I mean, the stars could not be related to this because the stars are so much closer. They're in our galaxy. But that galaxy itself is itself a galaxy, and we can see it here. We see the radio lobes, and we see, I mean,
correct.
For no reason to, I mean, if we look at it right here, the composite there with the three images together, you can see clearly that these radio sources are coming out. You have the current. If I was to be so bold as going to the right and left, I would think that the right side is closer to us, and the other side is going away, but I could be wrong.
Actually, if I've just looking at it, going backwards and forwards, where that 90 degree sits, you can actually see it in this image that we're looking at now.
I saw that as well. Yeah.
Yeah, it is actually visible.
Yep. Just barely, but you can also see where it's attached to these three. It looks like three large connections to this X-ray conglomerate around it, connected to the arms, and then of course the core is connected to this jet coming out the north and south. So this is, of course, each one of them is resonating at different frequencies. They have different, like one's an X-ray, and that's the going up and down. That's the ring that's storing electrical energy, And of
That's
course,
the X-ray only image right there, Neil. That's
that would be
purely
that's why it's storing the energy. It has X-ray vibration to it. It's storing energy that is being from the plasmoid in the center of that galaxy, which is its turn jetting out this material, which you can also see if you look closely in that image that you just had up with the red only. You can see it's coming out in jet pulses, just like Gareth described in one of his videos. Which was, and of course, you gave credit to Eric Lerner for pointing this out, which we just saw Sagittarius A go through, last month, something like that?
Yeah.
I'd like to ask a question, a pertinent question, I think. Where is all this matter coming from to form the plasmoids? From my eye, I'm seeing small little jets, pulsating jets. That's not enough matter to create these pulsars or these plasmoids. I think these,
so we see the right-hand rule.
The energies. I think the energy is creating matter in these images that we're seeing as well. People don't talk about it, but I think it needs to be talked about. That energy is creating matter in some of these jets and some of these interactions when a plasmoid gets kicked out of a.
Well, Halton Arp would totally agree with you. That's a quasar, and matures into a galaxy. That's his theory, of course.
But obviously, some of it as well. If we look at the cosmic web, then we believe there are obviously filaments that run right across the universe. Then it is entirely possible that those filaments provide matter, and that it's just a question of something condensing that matter at certain points. Mm-hmm. And you wouldn't see it because obviously the majority
it's a combination of that.
It's like a galactic scale coronal hole that's blasting out.
I think it's a combination of that. It's concentrating matter that's in the area, but it's also inside the plasmoid, creating matter inside the plasmoid as we speak.
Well, that's a property of Z pinching. If you have these layers, let's assume that the plasmoid is ejected and it's nothing but a plasmoid. Let's just assume it's nothing but a plasmoid. As it begins to be barfed out of the galaxy along this jet here, it's going to mature and pick up energy itself and generate its own magnetic field. Yeah. And it's going to start, the capacitive layers, which are double layers themselves, are going to start shorting out across itself and creating pinches. These pinches are going to condense matter. Anything it touches is going to pinch down. And it's going to continue that process until there is enough matter to actually have gravitational mass and what we would call electron density. This is a complete winging it theory, taking in, of course, the work of what I know to be EU. But it's, it's never been fully stated that way, I don't think, but I think that's a given.
Okay. Well, just a side note on all that stuff is that Cygnus A is a massive radio galaxy it's believed to be very far away. Mm-hmm. There is a lot of conjecture about the distance, but it's somewhere between 500 and 600 million light years is the believed distance to this particular object, and it happens to be the second strongest radio source in the entire sky, second only to the sun.
Wow.
What's weird, actually, if you look at that image, the more I look at it, the more I see that right angle going upwards again. It does it again above it, like a zigzag.
Hold on, Gareth. I'm going to open this up so I can zoom all the way in on it because it's. Pardon my arranging icons.
Don't worry about it.
Everybody's seeing what happens behind the scenes now.
No, we're totally offended that that's happening. Please stop.
Which freaking? How dare he?
I have 500 gigs of complete crap.
Well, listen, Gareth,
it does.
I was just reading about this, and I just
discovered
like a little
tail.
It looks like a spiral inside of a spiral, and the reason for that is that it's believed that there are two supermassive black holes colliding.
Oh my God! This is that picture. That's at the two galaxies colliding picture from Halton Arp's bullshit thing. Isn't that everyone seeing?
No. I mean, zoom out, Dan. If you zoom out further, zoom out a little bit. Above it, see the line goes. I'm drawing it on my screen as if you can see it, but
of course we can see it.
Here? See now,
there, and then it goes up again.
Now, you guys.
At the end of that, it goes up again. it's you probably need to. Yeah, it's not so obvious there, but just the image you had before. I'm sure if you played around with the contrast, you'd see it a little bit more. But it looks like well, dare I say, Harry Potter S on his forehead in the
Neil,
sky.
and you committed heresy when you said bullshit and Holton are put those two.
Okay, shut up. Okay, I'm sorry. Okay, I'm sorry.
All right.
But I meant I was just like it's the book. Like this is all his stuff. Like I mean, it's his bullshit. It's his stuff.
Welcome to the rabbit hole.
Yeah, you can see it better in that one. See, it goes up again and to the top.
Okay,
again.
I see where you're going. Like a little, yeah. Okay, like there's there we go. So there's a lot bigger a dust cloud around this thing. Because that's
why are those lanes? And I know Chris said that things do form naturally at 90 degrees, but that's massive.
Let me throw in what I was thinking. So maybe I'm totally wrong about this, but you know how the lowest pressure point is a sphere with a double layer, and as they grow outwards, they meet other shells and they push against each other like bubbles in a sink. Yeah. And so if you get a whole bunch of big bubbles they'll push against, you'll start getting pentagons, diamonds, hexagons all over the place very naturally because they form the boundary layer. That's my thought. And one more thing I was going to say, all these pictures, I'm looking at them and they look a lot like lunar features, like Aristarchus Plateau with the Aristarchus crater in the corner, the long chains of craters like the Herbig-Haro objects. Anyway, some thoughts.
No, that's totally awesome.
Everything looks like lunar features to you, though, dude.
Well, honestly, if you come watch, you'll see that like it's so hard to go back after you've seen these diamonds. Everyone's saying perfect circles on the moon. There are almost no perfect circles on the moon, actually.
I heard the moon makes you crazy.
It's easy to tease you about that. That's all. I totally respect you.
Thank you.
So what is it, Gareth? What is the point you're making, though? I don't quite grasp.
I don't.
Are you talking about?
Yeah, I don't have a point. I can't explain why it's there, but the fact that it goes up zigzagging across the that part of the image.
Are you talking about the dark edge?
The dark bits. Yeah. So clearly there is less matter
that's
there.
The 90-degree angle. Okay.
Well, okay.
Yeah.
I have a theory that could be wrong, but it has to do with photography. This galaxy is farther away and dimmer, maybe, in optical light, and they are literally cutting out pieces of it and brightening that patch up in a very poor form.
Yeah.
It wouldn't surprise me in the least. But
it's
of
important
course,
to remember this is.
It could be an occlusion.
It could be because of stitching. That could be Hubble stitching. I prayed it's not Hubble stitching. But look, there's Hubble stitching on this one. I mean, you can clearly see that it doesn't have the full image. It looks like all this plasma is swirling around these areas to me. But anyway.
Well, you should be able to get a deeper image than both of these pictures. I think you're right.
I think those squarish features are really there, man.
They're there.
It might be.
They're there. I can tell you from watching the Astro Imaging channel and stacking, these are wide field shots. They don't have those seams that you're talking about, and you can see them if you use levels in Photoshop, and you'll see the differentiation between the pixel density, and you'll see like Apollo shots, for example. You can very easily see the stitching. Shots like this, I would say that these angles are very common in geology. So why wouldn't they be common in celestial cosmology?
Yeah, I'd like to say something about what Rick's point was, is the energy.
Good point.
I think everybody, I don't know if it's been known for a long time, or it's been suggested that electricity current is from solid oxygen. And if that's true, and I believe it is, that if you put a lot of energy into something, eventually you will produce manifest solid oxygen. This is what the Sapphire project did. And then that transmutations come in and it raises up the temperature of everything. So this is where the material is coming from. Any source that will produce a lot of pulses of an arcing will, if you get enough of it, will start producing solid oxygen. If that theory is correct, and I believe it is. Therefore, that's where the mass comes from. Now, there's other points in there, but
we do have solid oxygen, James. We have rocks that have been tested. They're very, very deep blue in color, and they are tested to be solid oxygen stone.
Well, I mean, the Earth is mostly solid oxygen and silicate. So, take that for what it is. I don't believe that the things are producing suns. I think they're producing planets.
Well, what's the difference? That's the point.
Well, they're producing suns and planets, I think.
Well, no. But, I mean, this is where I liked it when Donald Scott. Yeah, before we get going, Dr. Donald Scott actually had this thing where he was basically describing that the surface area and the ability to process electrons, and of course, that alone is something that basically separates a star and a planet. If we just suddenly made the sun smaller, the rest of the planets would have to compensate, would still have to deal with the same amount of current, if you get my meaning. Anyway.
All right,
Daniel.
now let's move on. Let's move on to M87, made famous recently with the ultra famous quote black hole end quote photograph.
I'm getting some pictures, by the way. So
we're not going to talk about Robitaille's latest video because I'm still trying to process it. It's been less than 8 hours since I watched it myself, and my brain is frankly shattered from so many cosmology articles coming out in the past week.
Well, there's been a bunch, yeah.
I had to take about 18 hours of not thinking about cosmology because my brain was hurting pretty well there. Anyway,
I know the feeling.
Here's an image of the jet of M87. And this is a wonderful example of how perspective is everything when you're looking at galactic jets. If you're looking down the jet, it looks like a super bright object. Think of yourself in a smoke-filled room with a spotlight shining in your face.
Right.
Versus looking down the beam where it's not shining right in your face. I think everybody can grasp that. But the point is, these jets are able to reach out very far in the in intergalactic space and probably create satellite galaxies.
Oh God, yes.
What are the implications that this has upon the most recent understanding of the Milky Way? Well, everybody knows it's fairly obvious that Sagittarius A star is kind of off kilter.
Right.
It's at a significant angle. I don't know the exact numbers, but it's off on a significant angle. And so it's probably not interacting in a way. You live in the location of where the galaxy's field should be. You're viewing the Milky Way galaxy from the edge.
Right.
And that's kind of the same view that you're actually viewing Cygnus A from, the massive radio galaxy. You're kind of viewing this from the edge also. Otherwise, you wouldn't be able to see both jets almost perfectly perpendicular to your plane of view.
Within a few degrees, I would say, yeah.
Yeah, so I think that's an interesting feature to understand too. The fact that when you're on the B field plane, you're seeing radio. It's just amazing that this thing is able to transmit the most powerful radio waves we see in the entire universe from that great of a distance without conceding the distance, even if it's only 100 million light years or 80 million light years.
Well,
it's much closer than sources from inside the Milky Way galaxy is my point.
Oh, yes.
And perhaps it's just because the Milky Way galaxy's B field is messing with other incoming fields, which I'm sure it is. And of course, this is the problem. Let's don't get on a cosmic microwave background tangent, right? So let's just move on to more of the most.
Okay.
Another catchy name, XTE J1550-5.
I want that on a T-shirt.
It's just the most powerful X-ray source ever measured. So that they gave it this
and of
wonderful
course, if they
name.
get the black hole.
Now,
I'm scared now.
knows,
what else would they think?
Of course. Well, they have one power source. I understand.
Yes.
Everybody knows that the Crab pulsar is the most powerful X-ray source right now, but this thing dethroned it.
Oh, okay.
And only in 2001 did this thing stop emitting enough. I don't see the exact dates, but let me see here. The outburst happened in 98. And then they saw this happen. the one jet started to appear and then vanished. And so the theory was, well, the theory was all kinds of cartoonish stuff ultimately.
Well, it seemed to barf out a couple plasmoids in either direction, and one sort of petered out like a whirl in water that didn't quite make it. And it wouldn't surprise me in that case, but
something like that, yeah.
I like the term mathemagic.
Anyway, this I think this actually still is an X-ray source. I haven't looked this one up for a while.
But yeah, that's sort of like birthing pains. You notice in even the other picture of that other one, it had the pulses as well. These pulses should be indicative of these jets for obvious reasons.
And obviously, pulses is exactly what Eric Lerner had in his model, that they pulsed and were not on continuously. So
I wonder, and of course they're pulsing because of the slow. They're building up building up magnetic energy, and they must release that. But they're still at the center of a galaxy, so they automatically, the moment it's done releasing, it will again begin to spool.
Yeah, just going back to your point about why is it brighter than our Milky Way? I mean, for me, one of the reasons it obviously is brighter is because it is more active. You know, that you're looking at, a safer galaxy, which is got a highly active, in their view, obviously a black hole. In our view, it's an active plasmoid. Whereas the one in Sagittarius A is obviously considered to be dormant, although obviously we would raise question marks about what happened, 3 million years ago. But that's,
right.
Beside the point. It's relatively quieter compared to other galaxies which produce more. Now, the question is it further or closer compared to those, and therefore is that why it is of a higher intensity compared to others, because it is the closest, most active galaxy to us? And I don't know the answer to that.
That's a good question. Great question. That's exactly what I'm wondering also.
Well, we also have to recognize that the distance might not be accurate either.
Yeah.
And that becomes like the most powerful is suddenly a lot less powerful if you don't have it so far away.
But true, but the fact that we still receive, the X-rays here on Earth, and it is significantly more than anything else, still implies it's a pretty powerful source.
Oh yeah, if it's even, I mean, let's just imagine what it would be like when we describe two hurricanes merging. Well, we know that's a bad sign. That's a perfect storm type stuff. And what would happen if two galaxies decide to do the same thing? Because they're not just planets held together by gravity; they have fields and so forth, and they're going to start shorting out. And one's going to eat the other probably. But and it's not going to be a pretty picture. I can imagine that's what we're looking at, sort of like the sort of the consumption and all the extra energy it had to put into these fields made it push these things into glow mode, which in normal cases are in dark mode.
But these are young, so as far as what we can see, it is a young galaxy. It is, it's not a mature galaxy compared to the Milky Way. So it's a different scenario to the galaxy.
That's assuming
mergers.
Again what we know about the age of galaxies, but still that's fine.
Well,
I'm not. I'll let that go. I mean, why not?
Well, as far as we know, from what we're observing and what we're seeing, and I think in terms of the life cycle of a galaxy, I don't see much wrong with the mainstream view of, a safer galaxy quietening down after time and then becoming more dormant. That still fits in my mind with a lot of the EU concepts.
Yeah, no argument from me. A lot of the, just watching that wonderful video that Eric Lerner was actually in there. I think it was called the Universe Cosmology Quest video. It's a good one, and in that they describe Seaford galaxies, and you had great respect. You could see how far they've managed to push this question, like you're asking too much questions, and they push these people right on out the door, you know, and it's like, I bet you Jack Salentic would have a wonderful description about this, but still, this is obviously the question, what's going on here with these power levels. And now we've obviously explored a lot of this, but Daniel, you're obviously itching on this one. So what's going on here?
Oh, I just brought up the Gong 2 image to show you the current state of affairs with the local yellow dwarf.
Oh, that's the sun right now?
Yeah,
Okay.
yeah. That's this data is 1 hour and 15 minutes old. There's the current, you know, Z/B field schematics. So that's.
I like
we
how
don't
they
always show-
say B field, they say Z field. No one talks about the E field.
The E field. The E field.
Yeah, the electric field, the E field.
Oh, yeah. Well, I mean, it's kind of an essential part of all three, isn't it?
Well, what they do, and this is where the argument came from many times about magnetohydrodynamics, basically what this is all based on, is that it never takes into account the electric field. Like, why is that stopping there? What's causing the actual double layer, the capacitance? Because that is actually an effect. The electric field has an effect, and so on. It has and it's ignored in that field. What they basically do,
there's a chicken and the egg thing going on.
Well, no.
Is it electric current or is it a magnetic field?
Well, here's what they do. They basically take the M and they say it is equal to the E, and they basically make the resistance 0. Now, in layman's terms, to those who don't do any calculus, it's basically they take the let's say I over V equals R, or the Ohm's law. In this case, current over resistance, current over voltage equals resistance. Well, they basically make these numbers equal so that the R is 0. And that destroys that whole formula. But it's not 0 because there is a resistance. Otherwise, we wouldn't even be able to detect it. I mean, it would be 0. We couldn't see it. It would be invisible completely.
So let's. I don't want to interrupt you. But
No,
let's
I'm done.
Head back to the white. Let's head back to the.
I ranted. I'm done.
It was good. I fully endorse that. All right, so let's head back to the whiteboard and let's take this image of the Earth because this is the most realistic.
Okay.
Since it's so precisely measured, and let's consider what's going on with the sun's scenario, right? So where do those go to? Since the Earths go to the sun clearly to the current sheet, where do the suns go? I mean, isn't that the ultimate thing? We have practically no data on what goes on at the solar poles.
We have a few pictures of some spherules, apparently, that, well, it's not apparent, we can see them. And they go several solar distances away from the sun.
I think maybe Jim can answer that. I think...
I wasn't even going to say, because I know Jim is like going, yeah, I want to talk about this right now.
We orbit the Pleiades, and I think the energy that's at the center at the Pleiades is our solar circuit.
Well, it's part of it probably, but the question then again, Jim also had other questions about the actual the way the planets are arranged as well, implying that there is shells that each of the planets sit on, not just the sun, and the sun also has obviously the main current coming in, but then we also must know that there is attachments to the sun, reaching out from the North and South Pole to our planet, or so it seems. So it's a convoluted mess.
Hey man, look on the bright side. Look on the bright side. At least mainstream astronomers are finally admitting that they do not know if the Earth, the sun, the solar system, and the galaxy are gaining or losing mass. That's a step in the right direction.
Yes, at least they're questioning it. Hopefully later they'll come to the bigger question: what is mass?
Yeah, well, I
one
was
step
the
at a
guy,
time. I know.
When I took college astronomy, and the professor started talking about, I'm not sure which one this is called. Is it the solid state theory? the theory of the universe where the Big Bang happens, but everything just gets gravitationally pulled back in and then explodes again.
That's the great crunch, big crunch.
Yeah,
Became a sandwich at KFC.
Yeah, and so I asked the professor if essentially if you took one photon out, it would change the whole universe, and he was like, "Yeah, I guess." And it was one of these like auditorium classes, and everybody was like, "What kind of an asshole are you? Did you learn how to read? Did you learn how to read at 3 and learn about cosmic rays at age 6? What is wrong with you? That's not cool."
Oh, that's totally
why
cool.
are you making my life difficult, kid? I'm just trying to teach a class here.
He started talking about how there are opposing theories to the Big Bang, and he said, "Does anybody want to hear about those?" And a bunch of kids were like, "Is it going to be on the test?" And he was like, "Nope."
Well,
and everybody voted against it.
Yeah, that's actually kind of sad because that's exactly where the good stuff happens. I mean,
Can I throw in for a second?
Of course.
I'm just remembering the old quantum mechanics, the idea of Ed Witten, you know, the membranes, and the big, basically equating a Big Bang to larger membranes, anomalous looking kind of geometry smashing into each other at various points, creating multiple Big Bangs, infinite number of Big Bangs. And the idea
that
of relating
gets into
that,
pocket universes, yeah.
Well, possibly just that being an analogous to rarefaction and compression of waveforms, really. The fact that like life and death or Big Bangs and revivals of the universe all are kind of a similar process. So going in and out of, phasing in and out of existence as we know it. Anyway.
Thanks for freaking me out. I'm going to enjoy the trip tonight. It's going to be a nice drive. I'm going to be sitting there going, and you can just fade in and out of existence. I feel like, oh God, no.
Well, isn't the reason you don't fall through the floor that the floor is vibrating faster than the human body? That's the whole the principle of solidity is the fact that things are hard in relation to the fact that the human body is soft. There's this dance between two. Kind of the interchange between the two mediums is what creates the experience, right? So
science knows of no reason why I shouldn't be able to throw this bottle straight through that wall, except we've tried it and it doesn't work.
Isn't that, well, I would say that's the reason. The bottle is part of, vibrating slower, and so we can see it.
Yeah, sure, but now you've just belied the question. So because we're vibrating so quickly compared to the galactic medium, and we're only seeing the parts that are incredibly active, like the jets and the spiraling around Cygnus. But if we could see it sped up, would that look like a cell or an organ? Would that be connected to a whole whack of vascular systems? What's going on
here?
What am I sitting inside?
That's a good point.
Well, not only that, it's in dark. Some of it's in dark mode, some of it's in glow mode, and then some of it's in arc mode. So we have to be able to know what mode it's in and figure out, where the double layers are, especially when they're in dark mode.
Well, it's sort of like being able to pick out stuff from the noise as well, because there's a whole different level of like if we're speeding ourselves up, imagine that we could see fast enough that a human life is that fast. If we could see what the universe looks like at that speed, it would look completely different. We'd see things touching other things and bouncing off. Like, even though you would think these two galaxies are going to collide, we'd actually watch it come over, and you'd see they won't, because they're tubes now. With little pinches in them, and these two pinches just bounce off each other because you're like, of course, the magnetic field will repel them, of course. It becomes obvious because you're seeing them like wires as opposed to seeing them like you would see novelty plasma balls, is what I'm saying. Like something like that,
Here's one of the points I'd like to make. When objects like Deneb are spewing out cosmic rays, not Cygnus A, I apologize. When objects like Deneb are spewing out cosmic rays, this thing, when this is doing its thing and it's spitting out this jet, I would assume the reason that this jet looks like a bird, oddly, happening to be the tail of the swan. It just happens to look like a bird. And I'm not suggesting the ancients could see this, but the reason this looks like a bird is because this thing wobbles precessionally, just like the sun. And that means that there is a sheet of protons, like a spoke, through the entire galaxy looking like this. It's not just like a beam of cosmic rays getting here from Cygnus X-3. There's a sheet that's been spewed out for who knows how long, and that's going to be like
a spray, right?
Yeah, and it's just staying there, and so there's this like, it has all these weird properties. It can transmit electromagnetism, probably. It can accelerate protons and electrons and light and all kinds. It can do all kinds of weird things.
Well, it looks like a connection between two galaxies almost, the little friend and, of course, Cygnus X-3. I mean, that's what it could be. Could be we're seeing that kind of bridge. And that
perhaps the reason Cygnus X-3 is so energetic is because of Cygnus A, the radio galaxy. But in any case, Cygnus X-3 is super energetic. I mean, Cygnus X-3 is hyperactive. If you think I'm hyperactive, Cygnus X-3 is way more hyperactive than that.
That's crazy. What's going on? I mean, the amount of power, even, I mean, to be the brightest source that we see, brighter than the sun in X-ray from that far away, or even just outside the galaxy, and it's that bright.
No, wait. Cygnus X-3 is what we're looking at here.
Mm-hmm.
This isn't the brightest X-ray. The brightest X-ray source.
Oh, that was the other one, right? Sorry.
Is Crab.
Oh, that's Crab. Okay, that's inside our galaxy, of course. Yes.
The current brightest X-ray source is Crab pulsar, featured here.
I love the spinning GIF of that, where it just goes.
But this is the most powerful X-ray source ever measured. This is the one that temporarily dethroned Crab. I mean, I don't know. It might have just winked out. I'm not exactly sure, but it was quite a while ago. I think 2001. This thing kind of winked out. It stopped being so X-ray.
You could almost
friendly.
see an hourglass shape in it too. I mean, you see the north and south of the Squatter Man coming out of the disk. I thought that was pretty good.
On XTE J1550?
No, the one just before this one.
We seriously need to have a vote. We need to have a poll to see if we want merch that says XTE J1550-564, 3C.
I like that one. Yeah, definitely.
Most obnoxious one, because Cygnus A, you can almost even remember Cygnus A.
Yeah, it's too good. It
just has a ring. It just has a ring to it.
Yeah.
Can you spend all your money
numbers,
on T-shirt?
Look, it's got a dot in it. It's got my vote.
Well, I mean, this one has all the features, not this.
Save some money for food, Gareth. Come on.
This one here has all the features. It has meaningless letters, meaningless numbers. It doesn't have a period. It does have a dash. I think we should narrow it down to either 3C405.3 or.
I don't know. Every time I look at one of those, I just picture that if I do the translation correct, it will give me the Stargate coordinates. And I can use them to get to that planet. You know, like.
For sure.
Of course it will.
Through the Shapa Eye.
Yes, exactly.
You'll learn what the
Jaffa,
ingredients in Russell's
Kelchek
all-dressed
Demron.
chips.
Anyway, go on.
Neil, was the word banana smoothie to hit the chat? Just a loud reminder.
Anyway, keep in mind,
smoothie,
folks,
yes, thank you.
When cosmic rays get blasted out of a star, right, they don't show up like a beam. They show up like a sheet. Because you've got protons that are being followed by other protons that are being followed by other protons. So it's like, it's like the solar wind, but it's not the solar wind. It's coming from someplace besides the sun.
And it's being accelerated down the magnetic gradient of that, I guess we could say the magnetic field of the galaxy, which is quite strong, obviously, and much larger than the galaxy itself.
Yeah, and what I'm wondering the most is, let me finish drawing these arrows. There we go. You got to have the red one go in the opposite direction, right?
It's all AC current.
The real point is what's going on with the sun? All right, that's the deal. I mean, the Earth. I'm fairly convinced that the Earth's magnetosphere is just a result of a magnet passing through a field. And so, what are the ramifications of that? They're not good for your health ultimately, because that means that the magnetic environment can suddenly change, and so can basic all of reality with absolutely no warning whatsoever. So that's not a good thing. But if we can figure out how and why it does that, that would be a good thing, right?
Well,
yes, but without a magnetic field, we'd be dead as well.
I would imagine so. You may turn into a pile of dust or something without a magnetic field. I don't know.
No. The atmosphere
if
itself.
Outside to make a measurement, I would do it, but I can't do that. Sorry.
Just the atmosphere itself gives us significant protection against many deadly things. However, the magnetic field certainly freaking helps.
I would imagine so. Yeah.
It's also debatable as to whether that also creates life in a way.
Well, I do believe the energy passing through the Earth every second of every day from the sun is what causes our magnetic field. That's how it's generated, not a swirling ball of hot molten iron in the center.
Yeah, I don't believe it.
No, I agree.
Yeah, and the other thing is that the Earth is. I believe that Jupiter is actually creating the sun, a hollow sun, and the thing of it is that the Earth is at a fifth, and those are the harmonics, thirds and fifths.
Well, that's something that I don't.
Harmonics of the magnetic field lines that you're talking about.
Well, no, I think he's referring to octaves in regard to spacing of planets, but I do know that the planets do sound different. Clearly. When you listen to them, and obviously Saturn is cool and spooky, but
Neil, actually, that's a good point. The idea of octaves versus intervals is really interesting. Intervals within a series of 12 notes will create certain variations, but then octaves actually are like recursive, right? It's like quantization or jumping from a frequency or tonality to the next iteration of that. Higher
analogous to orders of magnitude.
Right.
And these magnetic field lines or tori that are within each other resonate at certain resonant frequencies, and that's how matter is sorted out and orbits around the sun.
Well, actually, I think Jim probably has more to say than I would on that, because he's the guy that actually studies this a lot more. So I'll let him speak up if he wishes to. There's a lot of people who are...
Jim, get it.
Well, just I would say that that idea that there's a magnetic dipole deep inside the sun or planets, that's clearly not working at all anymore, and I mean, see evidence everywhere, like with the Jupiter flybys. They found out that the magnetic field changes are too radical as the satellites flying past. So in other words, it can't be explained by a deeply embedded dipole, and that source of magnetic field must be just a little bit below the surface. And with the sun, you've seen now models where you can explain the solar cycle more by the sun having two separate charged layers that would lead to effectively independent dipoles that sometimes would come together and sometimes apart, and that's how they were trying to model the solar cycle. But one of those charged layers has to be right at where the sun shows solid body rotation, which isn't that deep inside the sun.
No, like 2,000 miles or something.
Would be the cycle. Like the layer would actually be the cycle, right?
But what if there's an energetic plasmoid in the center of the Earth heating it up from the inside?
Well, right now you're talking about the sun, but...
Well, the molten core and the hard crust, the action of them rubbing against each other may be creating the magnetic field, no?
Actually, I think you're making it really much more complex than it needs to be, but Jim, you wanted to finish.
Well, yeah, the whole dipole
idea. They don't need to rub.
Yeah, that doesn't even. I mean, the original idea for how a dipole is generated by, it doesn't even work. The mainstream actually knows that it doesn't work, and then they started having problems when they went out to. If you want to use that model, that molten core model, the problem was when they started finding moons that seemed to be very much rocky or icy, and they had a magnetic field. Then
how did you explain that?
Yeah, it's like all of a sudden you got to have different models then for every type of material. And
then
so
you really have no models. Yeah, that becomes the ad hoc universe. What's the point of that?
Right.
It's just a big story.
Right. Now, if things are composed of charged shells, then each one rotating will create a dipole field. And if they're not all spinning at on the same axis, that I think is the solution they found with the sun. Is like you might make this assumption that all these charged layers are all rotating the same, in which case you would have then maybe no net dipole field, or at least just one single dipole and that would have to be aligned with the spin axis. But if you accept that each charged shell can be rotating a bit independently, maybe leading or lagging, maybe one's more affected by the external environment, and then you get all these weird ideas that even the mainstream is starting to stumble on, like multiple dipoles for the sun to model the solar cycle, and not deeply embedded dipoles, at least in gas giant planets, and then you're back on the right track. But then you can kind of throw away the whole idea that we know anything about the interior of planets or even the Earth based on the magnetic field.
Exactly.
Well, there we have it. Yeah. And
hey, why did so much hydrogen come out of the deep boreholes? That's a question. That's a question for the ages, right there. How come the deep boreholes had so much hydrogen coming out of them? Is it because the Earth's made of liquid metallic hydrogen? That's a pretty crazy idea, right?
Well, I would hope not, but
electron affinity could explain. Electron affinity / availability could explain everything. I'll just say that and tease people's brains.
Tell us what electron affinity is, if you wouldn't mind.
Things that want electrons, like protons.
Okay, so an affinity for electrons.
So charge separation is everything. Instance, I agree.
For instance, let's say you have an object with electron availability, and then it's getting bombarded with things that have electron affinity, like protons.
Right.
What does that do? Causes current to flow, right?
Right. Oh, that's what you're trying to say, the protons from the field? There's an argument that the protons from the cosmic field, the cosmic rays, are actually powering the ionosphere, which
means they're probably
almost
powering
makes no sense. No, I don't think so. I think we are literally having direct current in those spirals that you describe here on the screen now to the right. How they are nested upon each other, those are the currents that are going into the poles of the sun. One will be predominant over the other, north or south, and that predominant flow will give you...
That's usually the central one, right?
No, I meant north or south. So one will have a predominant flow. That one will become the North Pole. So the South Pole of the Earth has more current coming into it. We can tell. We also know that we have a predominant field that makes our magnetic compasses point our north to the south magnetic pole, which is, of course, on the North Pole of our planet. I know this is crazy, guys. They're just reverse from what you think. But anyway.
That does not sound crazy.
No, I meant to the people listening. They're going, what the hell are you talking about? Basically, the right north of the planet is the south magnetic pole. That's all you need to know. So, but that's basically Ampere's law. Done. That's all it is. Which one has more current going in? This one. So so you're going to have the current, force, boom, boom, boom. So this is the current. I'm not sure which one it is. One of these things with your fingers. But anyway, it's going to give you the overall wraparound magnetic field, which of course is also going through the planet Earth too, at different layers. It's spiraling around the atmosphere. It's spiraling around the surface. and it's spiraling around the inner layers of the planet as well. And they're all probably at different, that's why we probably see a layer that they thought was iron or something at like 600 and some odd kilometers down or something, and it was all going in one direction. Well, that's the same thing as the but that was a mirror, but in reverse of the jet stream that we have going into the planet right underneath the aurora. So we have this jet stream coming in, but in the exact opposite direction, there's a ring current. This is the jet stream, and underneath the surface of the planet, there was a ring current in the opposite direction.
Yeah,
Like
but I mean,
this-
at the poles, you got the Birkeland currents coming in, and then you have directly in between them, you have things called Peterson currents that are connecting them like in a perpendicular line, basically, and then off of that spills the Hall currents, right? And I'm pretty sure that runs the jet stream. I mean, I can watch clouds line up all day on where you would expect Hall currents to be based on where you can see the poles.
Okay.
Let's don't stare at satellite images all day, but it seems fairly
well. If you're seeing,
reasonable.
I mean, there's a lot of things that you can see you get patterns, and of course, looking at these things, you're going to have a much better instinct than for that kind of thing. Like weather forecasters have an instinct that sometimes causes them to ignore their numbers. But there you have it, right? So,
hey, without summoning it, is Andrew Hall listening?
He's not here at the moment, but I will make sure that he listens to you.
Is it a coincidence? Is it a coincidence that there's an ocean at the North Geographic Pole and a 10,000-foot dimple at the South Geographic Pole?
No, I actually wrote that in my paper in 2016.
Yes.
It was I was using it as evidence of the geode-like nature of the planet, because all geodes have a bulge around the equator. They have a dimple at one end and a bump at the other that belies their polarity, which they seem to have. And I think that, this could be, now, of course,
it's experiencing a pulling force on one end and a pushing force at the other end throughout most of its existence.
Or at least some of it, yeah. And Mars has some of the poles as well, too.
Yeah.
Well, obviously, at an extremely crazy level on the North Point, but I mean, it has those spiders on the South Pole. So.
Anyway, I don't know of anything else. I mean, if anybody else has cultivated new brain cells and thought of something else to talk about.
Oh my God, I'm not even started.
Well, Mythos had a really good question.
I was actually reading that.
The Birkeland currents, and yeah, I see you replied to him. Jim mentions that we're in a local chimney, and the Pleiades are at the center, and we're in a tube-like structure with counter-rotating bands of energy that we can't see emanating out from the Pleiades, and we're in what Jim's refers to as the people refer to as the Gould belt. That takes 26 million years for us to orbit the Pleiades. Was that correct, Jim?
Yeah, that's based on the motion you'd get if you use the proper motion now. You'd get like 26.3 million years.
I'm not getting very good local chimney pictures.
I know, eh?
And you think
try astronomy or astrophysics after that word.
And
look, local chimney.
Oh, really? What?
There it is. There's the image. You've got it.
Yeah, there it is. Top
one.
right or left, top left.
It's gone now.
That was okay. All right. I didn't know that was good. All right.
The think of the Earth on this Gould belt donut, going up to the top of the donut and then going back down to the bottom of the donut. And I think we orbit around that donut, don't we, Jim?
Well, we're inside. All we have is its instantaneous velocity right now, which is just saying that we're consistent with kind of circling that and kind of going above the galactic plane. But we would be anyhow, just if we're circling that axis right now, we should be above the galactic plane.
Well, from my understanding, we're approaching it right now.
It's a tube like the internet.
Well, anyway, at around the galactic center is directly to the right. It says so. Yeah, it's on that slight angle that you had indicated it.
Yeah, it's kind of an unfortunate time that we live in to keep things straight, because we're kind of pinched between the central axis and the center of the galaxy. So a lot of times you might it's hard to keep straight where things are coming from, whether you're looking for particle or energy emission. Is it coming from the radially inward from our filament, or is it coming from galactic center? That's the same direction, unfortunately, because of where we are right now. And there's a lot of things you can clearly pin better to one feature than the other, and the mainstream doesn't have a mechanism for that, though. But I mean, if that filament has a radioelectric field, you see the problem that there's an electric field pointed pretty much from that central axis towards out where we are, but that happens to be on the same path pretty much as the center of the galaxy.
Yeah, so we have to go right through that Gould belt too.
That chimney axis, according to this map I see at the top, that's right next to the Cygnus arm. I mean, not to be like Cygnus, but yeah.
I wouldn't surprise me.
The Cygnus arm is right there where the pointer is. You see where my pointer is?
Yeah.
That's the Cygnus arm. So.
Yeah, but right, Cygnus is a long ways away, though, right? Still.
It appears to be one of the major galactic arms, but
isn't Cygnus up at the top of the chimney, Jim?
I take nothing for granted anymore.
Yeah, it's hard to see what I suspect is happening is that charge is flowing along the spiral arm of the galaxy, and then you should have helical streams. And what they don't show you is that chimney axis is actually defined by a stream of stars coming right down through the galactic plane. Now that's what you'd expect if there's a helical stream of stars going like up above the arm, across the top of the arm,
and then back down in a big spiral along the arm.
Right, because that Pleiades stream is not through the arm; it's next to the arm, but it just matches that. The only problem is we can't really trace. The easiest feature to map is that the neutral dust that forms that wall, that pretty much the white and gray there. That's what the mainstream can map out. But you lose, outside of the galactic plane, you lose all the dust. So you can't really tell where it goes after that.
It's quite the conundrum.
Yeah, again, the mainstream idea is that, and it makes sense. They see that stream of stars going down through the center there. So they think that over time, if enough of those stars were older and went supernova, it would blow out that channel. You couldn't just do it with one event, but maybe if a few stars along that stream went supernova over time. That was the early theory of how that whole.
And of course, it is itself. I mean, clearly it's a pinch. I mean, you can see it.
Right.
And now, or we could be looking at a sort of like a twisting spiral as well, of course.
Yes.
Yeah, you could be looking at a two-dimensional view of a three-dimensional series of objects too. In which case, you're getting.
I'm sure we are. Yes. In fact, there's some other different pictures that when you look at the artist rendition, you're going, that looks nothing like that. Because these are fields, and they're trying to envision what their eyes are telling them they're seeing, and they.
Well, I see the formless Squatterman in there too.
Of course,
right? With the
rings on the other side. Yeah.
Yes. See, that was.
Here's another catchy name, guys. G192-67.
Yes, Jim, you were totally right. That was one of the things that they happened to see. I think you were going to mention that was one of the evidences for an interstellar or interplanetary Squatterman. No, it would be interstellar. Interstellar.
Look at that.
One of the problems too is like the mainstream, they don't work together enough to see, like the people mapping that out aren't as interested in all the individual star streams as much to know where like all the blue stars are. But
we'd like to overlay that maybe. Yeah.
We've got like a stream of hot blue stars coming down the center, and then
We have a
that
jet out to
belt
one side there, I
is-
see.
There's a ring of blue stars around the side, so that makes perfect sense. That's where all the current should be, is like down
Right, a
in the
ring
center
current,
of the
yeah.
pinch,
Mhm.
and then a ring around it, and then current funneled through it. So all the blue stars are right where you would expect them to be if that's based on charge density. If that
See,
actually
why-
is a plasma discharge.
G192-67. That's going to be my latest T-shirt. I'm going to Vistaprint right after this. Screw you guys. I'm going to Vistaprint.
Oh, I can't wait to meet you guys at the EU.
Gareth is jealous.
I'm going to go bankrupt.
We'll make them available in the format of the British pound. Or
I was talking to Susan there, Gareth, and she goes, "I wish you lived closer. It'd be a lot easier to make sure that you can get to these conferences." And I was like, "I'll see if he can get here. I'll ask him. I'm sure he'll do something. We'll make it happen."
Any of Gareth's Patreons here? Help
like,
him out, would
Are
you?
you gonna help
There
me?
you go.
Like, are you gonna like other people are like? He goes, "Are you gonna come, Neil? Are you sure you're gonna?" I was like, "For shame, Susan. Of course I'm going to go." It's nice to hear. Anyway,
I would just like to add something historical note that I forget where it was, but the ancients said that Belgies or whatever is a fairly significantly far out thing was it was actually whatever, but it was the thing that was causing Mercury to wobble. And I said, how in the world could they think that thing up? But they said it as a statement of fact. It's this. There's no, and then they know all these other things. It's just impossible, unless they had really significant, like 10,000 years of tablets and stuff of observations. And I think they had them, and then they said they had them. But I was thinking, how in the world could this far off thing, specifically just get Mercury? I mean, this small, it doesn't make any sense. Then I realized, hey, the sun's going down or straddling a Birkeland current.
right.
It's affecting the Birkeland current, which is, since Mercury is the closest, gets affected the most.
Resonances.
So I just wanted to go.
Well, it could also explain why there's a thing called, and I didn't even put this on the list. There's something called the Mercury orbit anomaly, and it's a real thing.
Yeah.
I don't know exactly the specifications. I'm sure Jim or Gareth know more about it than I do, but it's it's a real thing, and basically they can't account for its variations in either speed or whatever, or angle, or I'm not sure what the problem is. But what is this we're looking at here?
That's Beetlejuice.
Oh, don't say it another time, guys.
This is Beetlejuice in the constellation Orion.
Betelgeuse,
and it's a very noticeable red star.
I don't have any mirrors
a lot of stars,
anywhere.
A lot of stars are kind of, across the spectrum, but you can see some, like Antares, for example, or Betelgeuse are definitely.
Yeah, Orion's belt points right at it. So if you find Orion's belt, the middle star perpendicular line from the belt points right to this star, and it is it's super red. I mean I think it looks redder than Mars a lot of the times.
Well, it's probably
in ancient times, Ceres used to be red. Now it's blue.
It's the if I'm not mistaken, this particular star, according to, is so large, and it happens to be shrinking at about 530 some odd miles an hour. Now I know that, yes, and it's shrinking, and the reason it's probably shrinking is because it's actually, what we're seeing is not the actual star. The star is way at the core of it. We're actually seeing the red coronal glow, which would have given us the purple dawn should any stars be inside of that glow. See, the star itself is really, the surface of the star is way down there, and there's a big etheric, well, I guess it's just called a coronal glow, but it's just like a fluorescent tube pretty much.
Look at that image. That's a better image yet. Look
Well,
at that.
if it's shrinking, then it's going to
That's why it's not even either.
turn
That's
turn
a
white
fantastic image there. Look at
and then
that.
blue.
I apologize. Go.
No, you're absolutely right. The change of from one type of spectral class to another, according to Don Scott on the Walter Hertzsprung diagram, basically is current surface current or current per cubic meter. On
Right,
the
it's
surface.
not seeking for electrons now; it's getting all kinds of them. So that's why it's shrinking, and it's going to turn
go to arc mode, yeah. And then then anything that was inside of that, any planets that were orbiting it, are now freshly cooked with their own little dinosaurs and all their little stuff. And then suddenly it shrinks down, and they are exposed to stars. And then perhaps maybe something crazy will come by, and then we get to see these dinosaurs get transplanted onto our world, and they eat us. I don't know how this movie ends, but
well, hopefully,
Isn't it
any
just a,
planets that are in there don't get.
that was my
in
rendition
the
of Battlestar
corona very
Galactica,
long.
but with dinosaurs. That's basically all I just did. So
Isn't it a life cycle? Just, I mean, I always feel like I'm stating the obvious, but like what we're looking at is essentially like what we see in human life cycles, bacteria, animal life cycles. There's zygote to growing up and aging and then dying, and
Well,
we're seeing stars and all
stars
these
don't
objects.
do that though. Stars do mature.
I would argue, yeah, I would argue that
no,
they do.
we had this debate before with Edo Cal, and one of the debates was because of the cooking of material into, or fusion of material into iron becomes the last stage, and iron being so good at conducting magnetic fields could make things more magnetic constricted and more star-like. So that because it would pull more currents in, and therefore you would be processing more currents the stronger your magnetic field. You see where this is going. However, the potential then after it's cooked, there's no real difference. You can turn up the current or down the current. The star will still be there. It will respond, just like the Sapphire project shows us. We turn it up and certain things change. We turn it down, certain things change. And one of the things that I'm often surprised about is we're sitting here at a period of great calm, but at any moment it could be all screwed up, and suddenly the properties on Earth are different. And I don't
Sun could
even
go
want to
dark.
imagine. Well, don't even pretend that. But I probably not though. Even if
But
this,
are we though, Neil? I think this idea of peace is just a concept. I think that we're always on the verge of destruction and being saved, and that part of being saved on the verge of destruction is what we conceive of as matter and life.
Okay, that could be very etheric, but I was thinking of more of a direct approach. Like if we are sitting there and someone is actually controlling the current or voltage across the solar plane, the heliopause, and then it just like it was a Sapphire thing, and then we turn it up just slightly, and then the whole thing gets these wonderful shells around everything, and all the planets got these wonderful shells around everything that were glowing. We would piss ourselves. And then we are only one turn of the knob away from that, is what I'm saying. That could happen tomorrow.
The population would piss themselves in fear, but we would piss ourselves in laughter because, haha, we're right, you're wrong.
Okay, you got to be there. Yeah, I'd be dancing.
I tend
probably,
to agree with Chris, though. I do think that a lot of what we see in biology is reflected what we see in space, and it's very hard for us to accept that might be true.
I'm actually fine with that with on almost every level, Gareth, like galaxies and stuff.
I like the way you qualify that with an almost there.
Well, no, I just
British
mean,
of you.
Well, I just meant that there's
that's a yes, but no.
No, you're good. You're good. Okay.
Always.
Us Canadians are British without a British accent.
Yeah, it's so true. It was just that there's that little aspect of once the sphere is cooked. I mean, it can be blown apart and made into other things and stuff. And yes, it will have a beginning and it will have an end.
But you're making an assumption on what the sun is, and at the moment,
you're absolutely right. You're right. There is definitely an assumption there. But I'm fully cognizant that the entire universe is a transitory phenomenon, probably that eventually will stop. I'm not sure when, I'm not sure how.
Well,
Galaxies are the same way. They
I'm not
eventually
sure.
mature and
There's a
age.
I
And,
agree with that, actually.
oh, now here we are now. Not good enough and not bad enough.
No, this
Get me
is-
right in the middle.
Stop or change.
Can I just acknowledge the agreement, because it was really tough to agree on things lately. So Garrett, thank you for agreeing with me. I just want to say, it's like, look, we do see bacteria, and it's very common to see a talk, especially Thunderbolt's talk, where at the end of it there's an analogy to look at biology and look at the interconnectivity of everything. To not take that into account, really, I feel like is missing a part of the puzzle. Like, so if stars last longer than us, that's very possible, but at every magnitude it seems like compression rarefaction, which we consider life and death perhaps, or good and evil, takes place at all magnitudes, and potentially infinitely in all directions, in both directions as we see it. So I do like that idea, because it makes understanding the universe and oneself possible in the same action.
Okay, I see what you're saying.
I'd like to add that the changes that you're talking about are in the geological record. Those borders are those changes in the change in cosmic function. Fortunately, I mean, my 80-fold reduction puts one of them in 375 of the common era, and that's when the Roman concrete changed its properties, and they couldn't make huge, gigantic buildings for 3 to 7 centuries after that, because they didn't have the border to do it.
So you're saying that the properties of materials on Earth, it wasn't just mixing in the volcanic ash, it was something else entirely, because this stuff could set underwater. I know it was practically magical.
Yeah,
That's
and
a fascinating theory.
It didn't just change it changed material. It changed everything, but fortunately, it wasn't a huge change that it could be. But these things are constantly happening, and this is the psychological part of the establishment science, trying to blind us from the fact that things are furiously changing. The cosmos is changing enormously before our eyes all the time, and they want to say, "Oh no, everything is fine, everything is cool. It's been that way forever and ever and ever." As far as our history is concerned.
Well,
And
you're
it's just
describing
not-
order out of chaos, James.
Yeah, they're just trying to deny everything, including consciousness. And
That's
it's like, how?
What if we are that resistance in order to grow? So all of life actually creates its own struggles in order to overcome them, in order to have life.
Oh,
whoa,
Yeah.
whoa!
There is no they.
You suddenly
we are
put
they.
me into that. What was that guy's? It was some sort of Buddhist lesson. Discomfort causes you to grow.
Right.
Like
It's true.
I gotta say, Chris, I hate that idea.
well, but
Thanks,
it's
Mike.
true. Like if you constantly
Probably
poke
'cause
at
it's
something.
true.
Yeah, because I mean, if you're constantly poking at it and going, but what about this? And what about this? I mean, here we are looking at this wonderful field here, and it doesn't take a genius to see that this is something very akin to what they drew on the Nazca lines, the giant
Or
spider.
an apple core.
Well, I meant
I mean,
on
it
the
also-
right side, but yeah, sure, the apple core on the other side.
yeah, that too.
And that's why I say we have to get the artists inclined in here, because we understand these things, but other people don't, or even care. But they do care about their unconscious assumptions about what life is about, and that's what we're running off of. And the materialistic philosophy is death. It's a death cult, and we got to get off of it. We need everybody in the arts to get going on this living, loving, if you want, conscious cosmos, because if we don't get off of this thing, it will kill us.
Well, actually,
Amen.
it'll probably kill a bunch of us before we go, oh, well, that was a bad idea. Just like, what was it? Pollution, scurvy, sanitation. Like,
I'm going to sound like a broken record, but we're here.
true.
Yeah.
It'll
We're
never
here,
be
so we're
accidental.
not. The whole idea that destruction is always around the corner is the motivator. Well, the reason I kind of belabor the point is because if people really want to make change, ultimately personal responsibility is the biggest fear. So when somebody ultimately says that they're the one creating the resistance in their lives, then they have to solve it, which is why it's not common. But ultimately, if you really do want to make a difference and you look at all these people that people idolize and look up to, these are the people actually doing something when they complain about something. So you're doing the dance.
You know, Chris, you're talking about completing a circuit there. Like there is true that there are external problems, and it's true that there are internal problems, and the solution is connecting the two. Like you have to understand your participation in the solution and the problem, whatever it is, in order to understand how to fix it. Like the bottom line is that that consciousness of both parts, my responsibility and not my responsibility.
Well,
it's beautiful, Daniel. By the way, I was going to talk about that.
Yeah.
The last thing I'll say is just the idea of the they, I think, is a paralyzer. If you're talking about branch growth and about path of least resistance, and if you talk about novelty and making having new definitions and changing things, right? Conviction, for example, is one of those fractal concepts that you have to plow for, and that's why if you always have a they or a death cult or an Illuminati, basically people will just be like, oh, I'm always stopped by this, hidden hand. But ultimately, you can also you can do something about it by like creating an alternative to replace them. And it happens all the time. Yeah, sorry.
Yep. Agreed. I
want to mention that John had a question there, John Smith. I'm not sure how binary electric stars work. Well, your picture that Daniel had up a moment ago, where it showed the, I think it was the Earth, sort of, you could see the two pipes where it was sort of connected to the solar wind that were coming down towards the poles of the Earth. Well, that's good enough. You can see it right there. See you later, Gareth. Great having you on. So basically, these are coming into the Earth. Now, these are probably at, I assume that these are like at right angles to the, like this right here looks like it's part of a tail, but I could be visualizing it incorrectly.
They're close to right angles of the solar wind. I mean, it's close.
I'm guessing that the bottom left image is the sun is top a little higher than the planet is, and it's aligned with that hole at the back, creating where the and then we have the magnetic sheet.
I think the
magnetic field lines connecting to the Earth.
What we noticed,
energy coming off of that.
I think the bow shock is going to be where you see the red, where the green and yellow lines connect. No.
Okay. Good. That's what I was hoping for. Okay. Good.
All right. Yeah, that's what I would expect it to be.
Okay.
I mean, I don't think. I think it's on the other side.
Well, you think that's a tail side?
I think. Well, what we're seeing is this isn't our magnetic field line that we're seeing. This is the sun's magnetic field lines that we're seeing. This isn't the Earth's magnetic field warping. I believe this is the backside of this massive curve.
I don't think that is. I think I go with Daniel on this one. It is the front. I think those are the two things that are coming down into the Earth. They're the currents themselves. The reason I wanted to bring that more up is because the connection to the sun might be more direct. The debate is whether or not, like, if this, we have depictions of ancient people who would scar their face or their chest and attach themselves to poles with strings going towards, and they would stand out in the sun, facing the sun all day. These are rituals that warriors would go through. And this is, I think, what they're depicting is they could see these things coming from the sun to them. They could see those two ropes. And I think that would be, well, it had a great impact upon them, obviously. And you could see it here, too, in this depiction, and that depiction right there. The blue at the bottom. Yeah, you can see how it's reaching in, and it comes in sort of like not even, basically.
This is a really bad day to be looking at this, by the way. The geospace is extremely weak.
Oh, well, that's fine.
This is an extreme solar minimum condition. Radio flux 66, solar flux units, everything is super low. No sunspots, no 245 megahertz radio bursts or anything like that. It's no X-ray flux.
Oh, it'll get lower. We're just at the beginning of the grand solar minimum.
It'll get lower at the end of next cycle. Hopefully not, but perhaps. I think this is cycle 25 has already begun.
Some people
I would say that Jupiter's red spot going smaller is part of that.
Keep in mind, Jupiter's red spot is a high pressure zone, not a low pressure zone. So it is an anticyclone.
Jupiter's red spot has been shrinking over time for a long time now. It was massive when it was first observed. Now it's way less, and it's just going to disappear eventually.
Probably
I think it was a birth scar. I think it was a birth scar, in fact.
Rings of Saturn are apparently also or diminishing.
That is also the case, yes.
Although it's going to take 50 million years. So send me an email if you see them go away completely.
I wouldn't be surprised if some of these go away a lot quicker. But I'm
thinking probably a couple thousand years and it'll be gone.
Are you kidding? You can actually see depictions of it through telescopes. It was massive. According to some of the old pictures, it looked like a sausage. That's how big it was.
1920. It was massive. Than that.
I mean, way back, like 1700 stuff.
I'm thinking that the red spot's not going to go away. I mean, it's going to get smaller.
Yeah.
But I don't know if it. I don't know. I'm not an electrical engineer or whatever that needs. But there's also a blue spot. So I've not heard anybody talking about.
There's one on was it Uranus or Neptune?
No, this is Jupiter.
Oh, Jupiter has its own? Okay.
Yeah, it does. It does.
Yeah.
And
the idea of growing a new storm in our lifetime might even be a thing.
The thing of it is in order for the sun to have a harmonic, it has to have something, measured to it. And then the only thing that they're using, or the reason the Earth is a fifth is because of the Jupiter's is 5.2 AU away from it. That's the harmonic. It has to be related to Jupiter in order for it to be a measurable harmonic. That's all I have to say.
Well, Jupiter has a massive effect on the sun. We know that already, and we know that it's pulling it right off that current, or pulling the sun off that current. I mean, because of the nature of the current passes just to one side of the sun, doesn't it? I'm not sure exactly if I saw a depiction of basically because of the sun is pulling it much further off center, or Jupiter is pulling it much further off center. And because of that, especially if you can get like many of the gas giants on one side, it pulls it quite far off of center.
That is one of the theories of the solar cycles in general, right?
Well, yes, and that's not even talking about the electrical implications. That's just...
Well, we know Jupiter orbits the sun every 11.8 years. I was wondering, and I asked this question last time, what's the solar cycle's cycle? Is it just 11 years, or is it 11.8 years?
I honestly don't know.
It's 22 years. It's in that, which happens to be the time.
It has a 22-year cycle as well, and then a 120-year cycle.
Yeah, but I mean the main one is that it takes 22 years for the solar system to go through the sun to travel down through the length of its own helisphere.
Guys, I need a nature break. I apologize. I'll be back momentarily. I know I'm sharing my screen, so
that's
be right back.
All right, sir.
I forgot my point. I'm sorry.
Well, no, it was just how long it was going to. You mentioned it was traveling the length of its heliosphere. I've actually never thought of that.
Yeah, it goes. Oh, I think I've said it before. Weird.
No, I mean,
at 20 kilometers per second,
yeah.
it takes 22 years for it to travel the length of its own heliosphere. So,
And that's in the direction it's going, or the closest possible direction. I just know it's not perfectly spherical. Is all I meant.
No, it's not. It measures from anywhere from 70 to 98 to 95, which takes approximately that amount of time. I guess maybe you could stretch it for Rick, but and I think Jupiter is the main. I know Jupiter is the main thing. I mean, to me.
Well, that's what I was getting at. Is Jupiter has a huge influence on the sun.
Well, I think it's making the sun because it's just a hollow thing, and I think it's making the sun around the Birkeland current itself. That's kind of like, and the stars are ratioed out to 1 to 3, the ratios. So I think Jupiter-like planets, which is what is really being birthed out there, and not suns, is what is creating all the systems itself. Because and I've said this before, the sun blinks out every once in a while. It's just not there, and so there's nothing for the planets to circle around it. And the outer planets are actually orbiting around Jupiter, not the other way around.
Well, if the sun blinked out, we wouldn't be able to see what was at the center if there was any gas giant there at the center. No, I think there is a gas giant there.
Not full. That's like saying the solid molten Earth, that's nonsense.
I think it's the same relationship as Saturn and the cosmic egg and the purple dawn of creation, that there's a gas giant in the center and there's a whole lot of space between it and the corona. Enough space for a planet to orbit inside there.
Yeah. But the thing of it is that the corona is being created by the transmutations that are happening on the surface of the sun. That's what's causing the heat, the friction, basically, of transmutation creation is creating the corona. And that's what the Sapphire project did, is they created basically the surface of the sun, and then the transmutations occurred, and then the heat started rising because of those frictions. And I'm looking forward to hearing what.
Well, I wouldn't depict it as.
I can't wait either.
They were doing the calculations. One of the things that I found about Sapphire's work is that they were all doing the calculations depicting on. I mean, it's not a hard calculation to do. You have a mass, you have how much heat you can get rid of, and how fast you can get rid of it, and then of course you have the current per square, I guess in this case millimeter, across the surface of this anode, and you can calculate with the relative modicum of efficiency when it should melt, because these are finite properties. Now, they noticed that it didn't happen exactly when they thought it was going to in many cases, and this is when some of these transmutation events were occurring. Now, this is one of those things that suddenly comes to mind, is that, well, what changed? Was it the reactions were taking energy or leaving energy, or were the properties of matter changing? I'm still open to that, because the idea of the sun just being made out of everything that every other planet is made of that we've ever found seems to be more homogeneous to me. Like that we should find that every sphere in the entire universe has generally gone through a similar process. Generally, I'm willing to accept that obviously the plasmoids at the center of the galaxy are pretty friggin' amazing pieces of stuff, natural machinery, I guess. But
Neil, can I ask, Just there are a lot of questions that popped up, and I want to act as the
let's do
audience
it,
here, even though
please.
there is a deep audience, and I think
Oh,
Eugene
look at
is in
them all.
chat
There's
as well.
61 of them. I can't
But,
believe
like,
it.
And who's all there, Chris?
I know, Mytho,
Say
John,
hello
anyone.
for us, would you?
I just want to say hi to everybody, and I know actually Eugene brought up a good point talking about fast radio bursts, FRBs. That's part of the title of the video. We haven't really chatted much about that.
Yeah,
I
we
mean,
should
maybe
probably do that. We had, well, I wanted Tanvir to actually, or Gareth, but he's gone now. We might have to just resort to Jim.
My only question early before that is just how do you reconcile Dr. Robitaille's idea of the sun having a real surface with the idea of, you know, a hollow sun or hollow planet, and Walt Thornhill talking about Jupiter potentially being hollow. The idea of hollow planets, hollow stars.
That's literally the conversation that we're entering into right here. Is when I'm referring to the mass problem. Because gas giants being gas. That's the exact same problem. Comets, as Walt Thornhill points out, are supposed to apparently be made of snow because of their apparent mass, but we find them to be rocks when we land on them. That sort of thing. That's all. And so we're not quite sure. There's lots of different theories. Is it liquid hydrogen? Is it hollow? Is the properties of mass changing? What are we missing here? That's the issue.
Do the plasma layers basically act like solid surfaces? You know, basically he points to
awesome.
To basically surface transverse waves on the sun that we do see visibly in the visible spectrum. You know, you see arches like splash down on the sun's surface. That's, you know, arguably real.
Well, this is giving you something to think about. This is when you talk about layers being real. I'll actually share this so you guys can see it. I'll put it right in there, but I'm going to show it to the viewers as well straight. So there's the paper, and we'll go to fast radio bursts in a second. But I'm just going to put up this one, which is the.
Neil, why don't you take the screen back, because then you can share whatever you have, because
sure, yeah.
I was mainly only looking at X-ray sources. And,
well, this is what we're going to go into here. I want to make sure that people. I'm going to attach on that. Let me see if I can.
Let me. I think I can pass it back here.
No, I can grab it. It's fine.
Oh, you can. All right, cool.
Yeah. Start sharing. Boom, boom. All right. So there's you. There's that. There's everyone chatting, and then I go.
Neil is an expert at YouTube, so.
Well. Yeah.
Excellent. Complete novice.
Here we go.
And I'm shadow banned everywhere, so please share the videos and watch them. Watch the
You know, I just wanted to add a little side note here is that the iron everybody's talking about, it happens to be iron 56, which is Peratt's 56.
Oh yes, I noticed that.
Great. See, and it's mostly stable because it's, you know, I just wanted to add that little small.
It's nice when we're talking about resonance that you notice that, yeah. Someone was going to say something? I'm sorry. No?
I just said thanks.
Oh, okay, cool. Anyway, up on the screen, you guys, I'm sharing this here. I don't know if you guys can see it, but it's the flyby anomaly. One of the things that, well, this is what they're happening to notice. Basically, when they're taking, they basically get an increase of kinetic energy during planetary flybys of spacecraft. And the speed that they gain is greater than predicted. So basically, something is causing the principle of mass to be different during these flybys. An anomalous increase
be less, wouldn't it?
No. The near spacecraft received an anomalous velocity increase of 13.46 millimeters per second. Now that's crazy, by the way. It's not. It doesn't seem like much, but there's a lot of them, as you can see here. And so this means that something, like they think, like, of course, here's some examples here. Dark matter halo around the Earth. Ooh. Modification of inertia during the Casimir effect. Unaccounted for transverse Doppler effect. But these are expected that we should have these anomalies if you're passing through bodies of differing charge. Like basically, do the properties of matter change as you pass through the shells? This could be evidence of that, is what I'm saying.
Well,
Guys, I don't know why I'm on the
we
screen.
said this.
I'm trying to be on the screen.
That's quite all right. Don't worry about it.
Cheers.
I got you covered up. It's okay. No one can see you. You were saying,
We
sorry.
said it before that the definition of mass in physics is nonsense. So so mass and charge pretty much the same.
Well, this is where it comes into the problem is like if it is variable, then are we looking at a liquid metallic sun? Are we looking at hollow bodies? Now, hollow bodies, as far as we know, according to experiment, should be about 40% of all the bodies out there. You know, that's just a given. 40% of all spheres that are made are hollow, according to electrical.
I'd say anything that's natural is hollow. It's just the nature of space itself.
Oh, did you notice that we found that diamond that had a diamond inside of it?
I saw that. And
That's
it's
crazy.
Just recursive, hexagons. We see it all the time in craters formation.
Well,
and
yes,
crystal
but there's a
lattices.
loose diamond inside of a solid diamond.
A loose? No, I thought it was shelled. Sorry. Okay.
Well, no, I mean it's not shelled. There's actually a piece of diamond inside that you can shake, and you can see another diamond inside of that diamond.
Oh, no, I didn't know it was a cavity.
I know, that's crazy. Like that, and of course that they say this throws into question yeah, of course it throws into question. But we see that with geodes all the friggin' time. Like a rock inside of a rock. Well, how'd that happen? Well, should that not happen? Therefore, in space with planets too. I mean, that shouldn't be impossible. Although that's ridiculous thinking about it.
Most of the diamonds were actually right on top of the surface, caused by shocks. It's not by. I don't think they're made by pressure, or I don't know.
Well, I just know that we have these giant, I guess, kimberlite pipe fulgurites, whatever you want to call them, that are the results of some of these footprints where we find these things, which is, I mean, that makes sense.
And then
We see transmutation where we do this stuff. Yeah.
Well, yeah, and then there's Peter Mungo Jep and talking about the electric snake that came out of the ground 150 miles and entered back into the ground, and
the mud fossil guy wanted to talk to
right?
us too. I don't know. I'm still on the fence about that kind of thing. You know what I'm talking about?
Oh, Mud Fossil University.
Yeah.
Yeah. Well, he takes things a little far, but he might not be, or might be correct and might be incorrect. I'm on the fence about some of the stuff that he says.
Someone really wants us to all caps address something.
No, he said sorry for that.
Oh, okay. Sorry for caps. I copy paste. Okay. It's like I just picture him. The electric view. This is crazy.
I addressed it. It was his comment about comets
it's
creating
gas, yeah.
a certain gas that we see on the Earth being created in plasma discharges, and that's a confirmation. Well, if you go to the Thunderbolts project and you watch Wallace Thornhill talk about comets, you definitely know that they're rock and they're not ice balls, and they're being electrically eroded. Even on the dark side where the sun isn't hitting it, we still see these jets coming out of the back of comets where it's not supposed to happen. And we see comets firing up way past Jupiter where they're not supposed to fire up because it's just too cold. The sun doesn't have enough energy for them to fire up, but they do because they're electrical in nature, not gravity and mass driven. The solar wind etches the faces of these comets, creating regular water, deuterium water, creating all kinds of gases, all kinds of different elements. This is the nature of our universe, the nature of our sun, creating elements on its surface and spitting them out in the solar wind.
Well, I think that they actually rips off. It's more of a chemical reaction when it's on comets, but I still hear what you're saying.
Chemical reactions are electric in nature too.
No, I wasn't denying that. But when you mentioned that, I mean, the reactions of like certain elements being formed on the sun under basically just constant electrical bombardment would not surprise me in the least. It seems that we're getting that on Earth with regards to lightning and other things like that. So it seems to be the way to do it.
Take a look at the Skype chat. I posted this link of an animated GIF of the whopping 8 repeating signals from deep space. But if you see this, you'll see that it actually really looks like a brain map in a way.
Guys, I've got to get going, so thanks for the call. I keep getting disconnected here. I don't know why I keep getting thrown.
Well, we're not noticing it. You seem to be doing great. So, but either way, we recognize that, and we've loved having you on, and I hope to have you on again. This was great talk, and I thank you.
I don't know why I'm getting thrown out. I just vanished again off the chat. But anyway,
thank you, man. Thanks.
And, other people were complaining about that too. It's a Skype thing, but
okay.
Yeah, it was nice to meet you, man. It was. I hope to hear from you again real soon.
Definitely.
Yeah. I'll be in touch. And
guys, check out his channel, man. It's right in the description. And
don't forget to subscribe.
They are into some scientific stuff.
So.
There you go. See, you know
anyway,
it.
Best wishes. Cheers. Thanks again, Neil. And hopefully we'll get the file. I'll put the video on my channel too. Hopefully in the near future.
It's all good, man. I'll give it to you straight up.
Yeah.
Take care, my friend. I think we just lost him again. Let me, so here's the picture that you were looking at here.
Yeah, I was just thinking, like, the first thing that came to mind, I was just reading up on FRBs, and I was just FRBs, that it looks like the brain maps, like the MRI brain maps when they scan a brain receiving information packets, and kind of.
I see.
Okay.
I don't know. That's what I saw. I think they're fascinating. It's this idea that they're very unpredictable, really, about radio bursts, and they're trying to create the agency scientists are trying to create statistical models for how to predict these and what they actually are. But we do see these already on the human scale in MRIs.
It would. I mean, we're not quite sure exactly where all of these things lie, of course, but one of the things that comes to mind is just understanding that, I mean, we see the same thing with gamma ray bursts, and that's just a different frequency than X-rays, but they have some of the same principles. Now, I'm not quite sure about this, so I wanted someone to be able to counteract me if I'm speaking out my ass, but they flash repeatedly, like lightning bolts strike the same area several times, and then they have a spike and a decay. That's with GRBs, but with FRBs, some of them are up and then down again, and almost like a square wave in some cases. I'm puzzled by the discrepancy. Things like that. Trying to figure out how far away they are is also an issue because we can't parallax them.
So problem being mentions something about, again, he's talking about the mainstream is now reporting that this gas is being detected in the plasma. So that's interesting that they're reporting it and they're confirming the electrical nature of a comet, apparently.
Well, yeah, but they won't acknowledge it. I mean, to even do that would be literally to say that Newton was fallible, and that would be like God. Like, that's challenging God to them. I mean, you might as well just stick your head in the noose as you go and walk off the stage at the Royal Academy in Oxford or whatever. I mean, just, am I wrong?
Well, no, you're not wrong.
I think there's just an implication that popularity should determine what science is, but in fact, we should just change the paradigm every time we have a show and explain that. Are you
sure? Because I personally think that people like the Kardashians should determine scientific policy.
Thank you for validating me.
Yeah,
Well, at
no.
least you got the magician's idea correct, making sure that you have a pretty woman to take care of things if things get bad.
Yeah, well, I suppose you're right. I mean, just go over here, look at her while I try to fix these numbers and make this look right. You know, like,
Keep the money flowing, please.
yes, please don't stop giving us money. I know that we said that we could do this and we didn't, but here's a picture of a black hole. Not really, but still, you guys keep going. Here's a picture of a girl making the black hole. Keep going. And what's next? You know, like, I don't know what's next on the agenda right now, but they're so many of these things seem to have, if you just sped it up. I mean, look at that picture that we were looking at here about the FRBs going off. So it wouldn't take a genius to just sort of scale that up to speed and put in the GRB gamma ray bursts in there, and then watch this just be a light of activity. You know, you would be hard pressed not to think of it as a brain doing brain stuff. You're right.
Or roots of a plant, or filamentary networks, neurons,
Anything like that,
the same lymph nodes. It's the thing is, you know, it seems very obvious, and people are like, "Wow, this looks like that, and this looks like that." But the fact is, sometimes you have to get off that fence in order to move forward on a process. You know, so really, it does look like that, and let's work from that vantage point to start identifying new problems and solving those. Right? I think it's at some point, it's like, essentially what we talked about before. If you finally give somebody a product like a battery that lasts 40 years, you've lost a customer. Or if you give them a scientific solution that actually empowers people, they're not going to come back to you. Or church giving you the salvation like on a particular day versus wanting you to come back every Sunday. That's the concept. But like, if you really do want to get science done, you actually do have to make decisions and move past certain baseline elements. So there is a fundamental understanding things look the same, that they act the same, and that we can use that knowledge of tree growth to determine things that are happening in the universe. I think that's like a fantastic, an inspiring way to think about it for me.
No. Yeah, but the counter of that is that the organizations themselves crave stability, which allows them to grow status and then get more money and all that kind of stuff. And if they make the change, then they lose status, and that's the dynamic they're really fighting, or don't even care to fight.
That's why I like to really listen to the dying words of scientists. They speak the most truth. Like, I mean, on his deathbed, you had Einstein going, "By the way, you should listen to Velikovsky. I might have been wrong." And then you have, of course, Hawking on his deathbed goes, "Yeah, dark matter, black holes, not too sure." Like, I mean,
before his deathbed, he said that. Well, before his deathbed, he said that there was no accretion disk around a black hole. Oh, wait, maybe what?
Of course, there's no accretion disk. There's no black hole. But I get you. He's a weird one. So, okay. So I'm going to. I actually got the
Neil.
Yes.
I'm looking for Daniel's YouTube, and he's really buried. Can you provide a link or tell me where I could find his YouTube stuff?
It's in the description of this video.
Okay, like the description on YouTube?
YouTube, yeah.
Okay, that's the one place I didn't look. Thank you. Of course.
Of course. So I was looking at the in addition to that, we have, of course, the we saw the flyby anomaly, the Pioneer anomaly. This is the other one. We have an issue there, which is very similar. Basically, it's off course. There's apparently an entire list of I didn't even know this, of astrophysical anomalies. I didn't even know that. I went down here to the scroll at the bottom of. I said list of unsolved problems in physics. and there's a whole slew of them. And I didn't even realize how many of them would be solved. Look at this list quickly and realize how many would be solved just by the electric universe theory alone, just by looking at it. I mean, right now I'd say at least half right off the top of my head I can see as an issue, you know, would be, oh, of course. That's of course why they work that way. Oh, of course that's why that works. Oh, that's why that works like that. That's of course why that works like that. Like those type of things. Just every one of them.
Wouldn't the spacecraft anomalies, wouldn't that be pretty much solved if they simply accepted that space was not void and it's really a form of atmosphere? Just question.
Well, I like your thinking, but the question becomes, why is the mass of these objects apparently changing? Like basically, when we swing something towards a planet and make it fly out again, turns out that it seems to lose mass on the way out or have gained mass on the way in or something, which makes no sense. And the same thing with the Pioneer anomaly. It's like 200,000 kilometers to one side now. But I think that probably has more to do with the same issue that comets have when they come in. Comets come in and they sort of do and this is Eugene, who's in the chat right now, was described this, where they just sort of do a flowery loop as they go around and they spiral, and it could be because of the right-hand rule that's causing this. Basically working in the magnetic field, and they have a slight turn to one side because they're passing through this field, and that's what creates this. But was that correct, Jim?
One thing I think with the flyby anomaly, there's two things that you should notice right away about just from the formula that they give you.
I saw that at the bottom.
Yeah. One is that the velocity can be either increased or decreased as it flies by, depending on which pole it leaves towards, basically. And the single biggest thing that should jump out at you is about the formula is it's not spherically symmetric, it's cylindrically symmetric. In other words, that's what you should be looking for a filament. If it has anything to do with this filament that we're strung on,
or the Earth's filament, basically.
Yeah,
because a lot of these are going through the close by angular shots of Earth. That's why we have such great depictions of their speed and stuff, because they're basically right in front of us when they go by. We shoot them out to the sun or something and watch them come back, you know, and that's what we're doing with these things, you know, trying to get them out to the outer planets and so forth.
There's I watched a video, I forget who it was, but he said that the rotations of Venus and Uranus being the counter was due to the like a Birkeland current, basically the coming out, and it was the counter rotations. Maybe that kind of idea is what is affecting them.
Well, I'll let Jim answer that.
Well, I know one of the mainstream ideas was that it was just rotation. You know, they like this whole idea of the warped space-time, and then a rotating object like the Earth might kind of drag space-time or wrap it up with it. But I think that's, I mean, obviously that's not what I think is happening, but I mean, that's kind of one of the mainstream approaches to solving that.
Well, yeah, we're not quite, and of course, when these anomalies come up, they're so minor, people just ignore them. And I think it's a very similar thing that they do with the GPS stuff, where they go, we see a discrepancy, it must be because of relativity, and they continue on. But it doesn't matter what the error is, that's always the answer. You know what I mean? Even if it's off by a factor, they're like, well, it's 10 times more than expected. Who cares? Relativity, adjust, move on. And that's not really solving the friggin' problem. That's just covering it up. And we do that a lot. It's like, we don't want to know the problem, so we change. We don't want to know the thing of light speed, so we We made meter dependent on light speed, so no one ever noticed the difference ever again.
Well, when you say you mean the mainstream. Just for clarification, the mainstream scientific community, not the electric universe folks.
Thanks,
we
Rick,
as
for saying
in
my
human,
mind.
Yeah, we as in stupid humans. There. The
No,
general
Neil.
stupid humans.
Jesus, man. Many others.
Hey, I'm not going to insult Jesus. I'm saying stupid humans. He seemed like a great fella.
Jesus is a biscuit. We need to sop him up.
Okay, you guys are weird. All right. So so basically, that's I don't know. Trying to understand these anomalies are, well, one of them is fairly easy. The one that I love bringing up, it might have something to do with what we were seeing there, but why these things were affecting us at such range was the for example, that galaxy that we see exploding there, that we saw the picture Daniel had up, and we saw the 3 layers over top of each other. Well, that could be something that's much closer to us. It could be something that's ejected from our galaxy, for all we know, and much closer and much smaller. That's how much redshift we know nothing about, and we only know it's an issue. And this is one of the last anomalies that I'm going to bring up before the end of the thing. We have about 8 more minutes. I don't like to go over 2.5 hours if I can handle it, unless it's really good. So it is, it's called the Fingers of God problem. I'm going to just type it in here.
But this is really good.
This is really good shit. Let's see. Fingers of God, images. Look at the images here. There it is. Okay. This is a pretty good depiction of it and how messed up it is. Well, this is describing the problem, but it's not giving us an issue. Okay. See if I can go, because I don't want to. This is a pretty good picture of it right here. But basically, if you understand that all of the plots for all of the quasars are stretched out from us being the Earth, our point of view. If that's the case, then we are obviously the center of the universe, and that's obviously ridiculous.
Woohoo! I always thought so. No, I'm joking.
But you can see that these depictions are quite stretched. It's just looking at any of these pictures, and this indicates, just unbiased, just an obvious look, that they are related to one another because of the way that they're stretched out behind other objects. So they're related to foreground objects, all pointed towards the Earth, which means this little cluster of stripes right here are a whole whack of quasars being ejected from something down here, and they're all in this line together. And they're all actually not at this redshift distance. They're all bunched up right around this nearby object, this foreground object.
Well, from my understanding of quasars, NASA says they're the furthest objects in the galaxy.
Because they are
the universe, sorry. Well, yeah, but they say that because of their redshift, that all of them are way, way out there, and there's none of them that are close to us. Yeah, right.
Well, and you can see just by this, you see the red marks there very clearly. They're all related to each other, and these redshifts must be anomalous. And this is what Halton Arp has been harping on for his entire career, and for good reason. Because if you can't see this, you should literally just get up and get out of the friggin' room, because it's so obvious it hurts. And they won't
make room
acknowledge
for the
it.
next guy with the telescope time already. Come on.
Yeah, it's crazy.
Well, it's very interesting that you say that there's 3 of them, because that's what my lady's cosmology is all about, the shape of the universe itself. I'll tell you about that some other time, I suppose.
Oh, okay.
She also has other things, so.
Well, I just want to, if anyone wants to discuss this particular issue, because obviously it's the redshift that becomes the distance issue, and this is why I bring it up here again. Quasars are supposed to be the furthest and most radiant sources of energy, supernatural in power, until you bring them close by, and then they become reasonable again. Well, is Cygnus really far away, or is it much closer? And this brings up to what James was saying, where we're really not sure. And we can't even get an accurate depiction of the speed of rotation of some of these galaxies. So,
Well, we do have that interesting diagram. I need to talk to my lady about that, how it fits into her own thing. But she's got a system where the Earth is, not the Earth, the galaxy, the universe is 15.9 billion years old. Just keep that number in your mind, and one day when we get to it, you'll understand what the significance of that. But the other thing is that she says that the cosmology itself is that there are three stages of the cosmos coming together. One was first 15 billion years, where it nearly came into manifestation, but it's like a percolating thing. So the first 15 billion years, just percolation. The second was another percolation, and then the third was the one that came out. And that's what we're presently at 15.9 billion years. That's her thing. And so when it comes into the structure of the cosmos itself, it comes into play. So I just wanted you to know that.
no, I didn't actually.
Well, nobody does, because she's not a public person. She'll never speak. I have to speak for her.
Oh, okay. Well, I actually forgot about this one totally, since this is absolutely crazy. That great wall that we see across space that shouldn't be there is probably a lot closer to us as well. We're seeing structures that are supernaturally large, and they could be just part of our galaxy. That's another thing that seems to be popping up from here to here again. See, the hero worship issues that we were talking about are part of this problem. Because, I mean, you would literally throw academia out on its ear if you accepted this to be true. I mean, this is a cleaned up version. See, it's all gone. That's only that removes all the quasars. You just have galaxies and everything looks fine. The moment you start putting the quasars in, it starts getting all stretchy and weird. And also in rings too. It's kind of weird. Away from us for some reason, which again can't be. I mean, we're not the center of the universe. Sorry. We just think we are.
Well, actually, my lady's cosmology, she's indicating that there's three systems, and that we're kind of like in the center of our system.
So we're Midgard?
So, well, I'm just saying our perspective is that we see things from that particular perspective. Even though we're not like 3/4 of the way at the end of our particular region.
I would be bothered now if the book that she writes does not have the words like Heimdall's vision in it or something.
Well, I don't
No, it's just because you're talking about seeing, and never mind. He's just that god. I've watched too much Marvel. All right. Well, guys, this has been fantastic. I have enjoyed today immensely.
What a nerd.
I know. Well, I prefer the term geek. My nerd is reserved for when I talk about maths. So, you know how it goes. Anything that you guys wanted to say before we took off, friends?
Great show.
Thank you.
Amazing
Yeah,
show.
it was a
Thank
great
y'all
show.
so
Thanks.
much.
You guys
I feel
make it
both
possible.
Smarter and dumber.
That's so smarter and dumber. Chris, do you have the moon show coming up soon?
I did a little bit late last night with M42. If anybody really wants to see great like nebula shots, and I don't know, maybe sometime soon I'll ping y'all.
I'll be around.
Don't forget to
definitely.
say hello and say goodbye to everybody in the live stream chat.
I'm not done yet.
Thanks all the Take Back Space people and everybody chatting in the chat.
We have like almost 70 people in here.
And I just want to say, problem being, I agree comets are electric. So thanks, everybody.
I'm not subtle, Neil. I'm not subtle.
No, this has been thanks everyone for coming out here. Ben, John, Sully, of course, you're the most amazing. You're always here. So really, truly thanks. Of course, Eugene popped in just to make sure that everyone felt a little bit dumber. And so thank him very much for being here.
I didn't even see that. Hi, Eugene.
I know.
Bye, Eugene.
He's totally awesome. He's just the best. All right. Well, I'm going to sort of let this go then. Well, I do thank you very much, friends. Been real.